Hi everyone, this is Professor Oaks, and in this video we're going to discuss solving systems of equations by substitution. So, in the last section we discussed systems of equations that look like this. X equals 2y plus 5, and 4x plus 3y is equal to negative 2, but we solved these by graphing each of the lines. But in this section, we'll solve these by a different method called, again, substitution. So what you need to do is solve one of the two equations for one of the variables, and this equation is already solved for x, and then substitute that into the other equation. So we're going to substitute the x is 2y plus 5 into this equation here. So what we have then is 4 times, and we'll use parentheses, 2y plus 5 plus 3y is negative 2. And then we'll distribute the 4. So 4 times 2y is 8y. 4 times 5 is 20, plus 3y is equal to negative 2. Combine the like terms. 8y plus 3y is 11y. Then subtract the 20, so plus 20 is negative 2. Subtract the 20, so 11y is equal to negative 22. Then divide by 11, so y is equal to negative 2. But if the problem asks you for x, then you would substitute that y equals negative 2 back into this equation right here. X is 2y plus 5 to figure out what x is. So x is 2 times negative 2 plus 5. Remember that y was negative 2, and then x will be then negative 4 plus 5, or x is 1. So there is the solution. xy is 1, negative 2, and we didn't have to graph both of the lines. So that was, again, one of the examples. So why don't we do another example here, and let's try this one here. Y is equal to 3x minus 3, and 2x minus 4, y is negative 8. Again, the first equation is already solved for one of the variables. So here, this is solved for y. So we'll substitute the y equals 3x minus 3 into this equation here. So we have 2x minus 4 times, let's use parentheses, 3x minus 3 equals negative 8. Distribute the negative 4 here to get 2x minus 12, x plus 12 equals negative 8. Combine like terms, 2x minus 12x, negative 10x plus 12 is negative 8. Subtract 12 on each side to get negative 10, x is negative 20, and divide by negative 10 to get x is 2. So then, if the problem wanted you to figure out what y was and not x, then you would substitute the x equals 2 back into this equation. So y was 3x minus 3. But if x is 2, we have y is 3 times 2 minus 3, or y is 6 minus 3, so y is 3. And then the solution would be xy is 2, 3. And again, we did this without graphing the lines. All right, so let's do another example here. Let's see, what do we have here? We can do this one here. 2x minus 4y is equal to 4. and 3x plus y is equal to 20. And now we need to solve one of the equations for x or y, and it doesn't matter which one. So what you could do is, if you wanted to, there's several things that you could do. All right, you have 2x minus 4y is 4. You could solve this for x to get negative 4y. Well, I actually forgot. I didn't actually. Here, I should write solve for x above here. So solve for x. So if we add the 4y to each side, we have 2x is equal to 4y plus why isn't this whiteout working? What a time to be alive. 4y plus 4, then divide by 2, so x is equal to 2y plus 2. And then that could be substituted into this other equation. All right, so 3x plus y is equal to 20. So we'll substitute this, substitute in here for x and use parentheses. So 3 times 2y plus 2 plus y is 20. Distribute the 3. So we have 6y plus 6 plus y is equal to 20. Combine the like terms. 6y plus y is 7y plus 6 equals 20. Then subtract the 6 from both sides. So 7y is 14. Divide by 7 on each side to get y is 2. But then if the question asks for x, we can substitute that y back in here to get x is 2 times 2 plus 2, or x is 4 plus 2, so x is 6. And then the solution will be xy is 6, 2. All right, so again, there's more than one way to do this, but one way is to solve the first equation for x. All right, so let's try another one. Let's see, we have 8x plus 6y is 26, and 3x plus 3y is equal to 6. So again, we can do either of these two equations here. So 8x plus 6y is 26. If I solve this equation for x, then I have 8x is 6y equals 20, negative, negative 6y plus 26. Then divide by 8. So x is negative 6 over 8y plus 26 over 8. So x is negative 3 over 4y plus 13 over 4. So I might not want to deal with the fractions. So I could take the same equation and see if I solve this for, say, y, if I'll get fractions. So we have, let's see, what do we have? 6y is negative 8x plus 26. Divide by 6. And so y is negative 4 over 3. X plus 13 over 3. I still get fractions, so maybe I could use this equation. 3x plus 3y is 6, and I solve for x. All right, so I can subtract the 3y, so 3x is negative 3y plus 6, divide by 3. So x is going to be negative y plus 2. Now I don't get fractions. And then I can substitute this equation that I have solved for x into the other equation, and I don't have to deal with the fractions. I could deal with the fractions if I wanted to, but I'm not going to. So 8 times negative y plus 2 in parentheses plus 6y is 26. Distribute the 8. So negative 8y plus 16 plus 6y is 26. And then combine like terms. So we have negative 8y plus 6y, negative 2y plus 16 is 26. Subtract the 16, so negative 2y is equal to 10. And y, when you divide by negative 2, is equal to negative 5. Then you can substitute the y equals negative 5 into this equation right here to solve for x. So x is negative 5 plus 2. So x is 5 plus 2, or x is 7. So the solution then is xy is 7, negative 5. So what a time to be alive. All right, so again, I just did this problem this way to avoid dealing with the fractions here. So let's try another problem here. So hopefully you are enjoying this tremendously. I know that I am. So we have 5x minus 3y is negative 1, and 15x minus 9y is negative 3. So let's go ahead and solve one of these equations for x or y. So 5x minus 3y is negative 1. So we have 5x equals 3y minus 1. And then x is 3 over 5y minus 1 over 5. All right, so now I'm going to just do this one with the fraction just to show you how one might work anyway. So I can solve this by substituting this into the other equation. So I have 15 in parentheses 3 over 5y minus 1 over 5 minus 9y is negative 3. Distribute. So I have 15 times 3 over 5, 15 times 3, 45 over 5y minus 15 over 5 minus 9y is negative 3. 45 over 5 is actually 15, so 15y, 15 over 5 is 3 minus 9y is negative 3. So the fractions actually are gone anyway. And combine like terms, 15y minus 9y is 6y minus 3 is negative 3. Then I will add the 3 to get 0. So 6y is 0. And then y is actually 0 here. So now, and then to find x, we substitute that y equals 0 into this equation over here. So we have x is equal to 3/5 times 0 minus 1/5. So x is negative 1/5. So then the solution is going to be xy is negative 1/5 and 0. All right, so hopefully that will be okay to everyone here. Now let's try another one. All right, so let's label this one number 6 here. The opposite of x plus 3y equals 9, and 4x minus 12y is equal to 36. So we'll solve one of the equations for x or for y. So let's solve the first equation here for x. The opposite of x plus 3y is equal to 9. So then you can add the x to get 3y is x plus 9. Then subtract the 9 to get x is 3y minus 9. Now I'm going to substitute that into the other equation here. All right, for x to get 4, and then in parentheses 3y minus 9 minus 12y is equal to 36. Distribute the 4 here to get 12y minus 36 minus 12y equals 36. Combine like terms. 12y minus 12y is 0. So negative 36 is equal to 36. And that is actually a false statement because negative 36 is not actually equal to 36. And so then that means that this system has no solution. All right, so false means no solution. And so that actually means that this is a system that is inconsistent, or an inconsistent system. So again, that's another way of just saying that this system of equations has no solution. All right, so let's try another one here. So hopefully you are truly enjoying these today. So let's see, we have 12x plus 3y equals 4, and 4x plus y equals 1. All right, so we'll solve one of the equations for x or y. So let's solve this one here for y. Again, it doesn't matter which one. So we have 4x plus y is equal to 1. Subtract the 4x to get y is negative 4x plus 1. Then I'll substitute that into the other equation here. And then remember to use parentheses. So we have 12x plus 3 times negative 4x plus 1 equals 4. Distribute the 3. So 12x minus 12x plus 3 is equal to 4. 12x minus 12x is 0. So 3 is equal to 4. And then I see here that 3 is not equal to 4. So this is a false statement. And therefore, there is no solution to this system. And that means it is an inconsistent system. All right, so we had 2 inconsistent systems in a row here. All right, so now let's try another one here. So here we go. We have 6x plus 8y is negative 22, and negative 3x minus 4y is equal to 11. So we can solve one of these equations for x or for y here. Again, it doesn't matter which one. So let's just, I'll just pick this one. So solve this one for, let's just say x. So 6x plus 8y is negative 22. I'll subtract the 8y to get 6x is negative 8y minus 22. Divide by 6. to get x is negative 8 over 6y minus 22 over 6. And I'll reduce to get x is negative 4 over 3y minus 11 over 3. All right, so now I'm going to substitute that into the other equation here. So here is the x, and we'll use parentheses, negative 3 times negative 4 over 3y minus 11 over 3 minus 4y is equal to 11. Distribute the negative 3, so I have 12 over 3y plus 33 over 3 minus 4y equals 11. 12 over 3 is 4, so 4y. 33 over 3 is 11. Minus 4y equals 11. 4y minus 4y is 0. So we have 11 equals 11, which is a true statement. So remember in the last problem we had something like 3 equals 4, which is false, but 11 equals 11 is true. So this means that there are infinitely many solutions, and that means that this is a dependent system. So if you get a true statement, then this will be a dependent statement system. Yes, dependent system. If you get a false statement, then this would be an inconsistent system, like in the last example. So this, I think, will conclude all of the examples I'm going to do for this section here. I hope you enjoyed this video and that you are already looking forward to the next one. What a time to be alive. Thank you and have a great day.